Good morning. My name's Katie Rose. I'm our STEM program assistant here at Science City and Union Station. Thank you all so much for being here this morning. I know it's early. It's my pleasure to introduce our speaker today, Patrick Gillespie. He received a Bachelor of Science in Chemistry from Kansas State University and has been with the KCPD Crime Laboratory for about 5-ish years. Yep. Okay. He is trained in seized drug analysis, fire debris analysis, and bloodstain pattern documentation. Ladies and gentlemen, Patrick.
Thank you, Katie. All right. Good morning, everyone. Yes, my name is Patrick Gillespie. I'm a forensics specialist 4 in the chemistry section of the Kansas City Police Crime Laboratory. Today we'll be talking about forensic science and exploring several disciplines in the field through their application in a real case. We'll start with an overview of what forensic science is, a general understanding of the kind of work we do, and walk through the case, and then talk about what kind of educational requirements and special requirements there are for getting a job in a field like this. Thank you to everybody for coming out today for this, even those of you who are here for just extra credit. All right, so let's start with the definition. What is forensic science? The National Institute of Standards and Technology defines forensic science as the use of scientific methods or expertise to investigate crimes or examine evidence that might be presented in a court of law. That's a pretty all-encompassing definition, but a little wordy. Practically speaking, forensic science, like any other field of science, is trying to answer questions. So the types of questions that we face are things like, are there any drugs in this unknown powder? Whose blood is this at a crime scene? Or did this gun fire that bullet? The answers to those questions are the way that we make connections in a case. We have to uphold the same standards as any other science, that we are using data to support our conclusions, that we are peer-reviewed, and that the methods that we use are valid and reproducible. All of that with the added weight that our work could be used to convict someone of a crime. As you can see, there are many areas of forensic science, and we will not be touching on all of those today, but we will be primarily focused on criminalistics, which is analyzing evidence used in a criminal proceeding. So these are our sections that we have in the lab, as well as some of the subdisciplines underneath them. Like I said, I work in the chemistry section, so I primarily do seized drug analysis, but I'm also a member of the fire debris section and the bloodstain pattern analysis section. Most analysts will train typically in 1 or 2 disciplines, but cross-training does happen from time to time, depending on the needs of the lab and the educational opportunities. So what do we do? In a general sense, the first thing that we do is we are analyzing evidence. We spend probably about as much time in the lab as we do at our desks, the way the technology has shifted nowadays. We spend a lot of time in the lab working on preparing a sample for analysis, running it on instrumentation, gathering data, and then reviewing all of that work back at our desk. Once we finish our analysis, we will write a report to share our results. This is the most common way that we convey our information to all of the parties involved. The report will go to the detective, the prosecutors, the defense, and most importantly, the trier of fact in a case, the judge or the jury. Technical review, we will touch on this later, but for now, everything that you need to know is that every report that we release from the crime lab is reviewed by more than one person. It's the analyst as well as a second person checking out all of our work. Courtroom testimony. This is a part of the job that isn't as obvious as everything else that we do, but it's something that does come up from time to time and is just as important as everything else. We have to be able to share our results to a group of people, a jury in most cases, that are on average not forensic scientists and are on average not even scientists. And we have to be able to explain that information in a way that makes sense and conveys what actually happened. And lastly, continuing education. If there is a new trend in the type of drugs that are being seen on the streets, or if there is a better technology for analyzing DNA, we want to know about it. Forensic science as a field is always going to be one step behind the people who are committing crimes or doing things to further that endeavor. And so any way that we can get a leg up on improving our analysis or making things better is an advantage for us. Forensic science is a very collaborative field. While there is research done, there are patents in forensic science, there are research articles where people are protective of their work. We want to be able to share that information as much as we can with other agencies, because it doesn't do us any benefit as a lab to have a technology or a technique that helps us, but not knowing that somewhere else may hinder their ability to do their work. I'll say sometimes continuing education definitely feels like studying, like you never really leave school, but it's made better by the fact that I get paid to do it now. So what do we not do? The first thing here is we do not solve crimes. It's one of the most common things that I get people saying to me when I explain or that I'm a forensic scientist. It's like, oh, you solve the crimes, you catch the bad guys, you put people in jail. No, I don't. Each area of forensic science is one piece of the puzzle. And while we do contribute to a case, it is on the detective and the prosecutors to prove beyond a reasonable doubt that someone committed a crime. And the jury, in that case, is responsible for judging their work in that field, or in that endeavor, rather. We do not make arrests. So, like you might see in CSI, NCIS, however many crime shows there are nowadays, we do not go from picking up evidence in the field to the murder board back at the station and linking the suspects together and go out and arrest them and interrogate them. We spend most of our time in the lab doing work there. And nowadays, most forensic scientists are civilian positions. It used to be the case that you would see mostly law enforcement in the field, but as the scientific rigor has increased over the last few decades, we've shifted to mostly civilians in these types of positions. And lastly, we do not misrepresent our results. As I said earlier, we are all one piece of the puzzle. There is no one single piece of evidence that's going to tell you who done it, so to speak. Every science has its limitations, and we have to be aware of those limitations so that people don't get the wrong idea about what we've done in a case. So, I think the best way to walk through our job is to work through what has happened in an actual case, in this case, a gas station murder. Disclaimer that there will be a couple photos of a dead body in the next few slides. There's nothing gory or explicit. I'm sure the true crime junkies in the audience have probably seen worse than what will be shown here. Most of the focus is going to be on the work that we did. Some details have been redacted or modified as necessary. And let's get started. So we start with a 911 call received from a gas station store clerk who reported that a customer came inside and informed him that there was an unresponsive person laying on the ground outside. Our homicide unit responds. The store clerk said that he saw the victim prior to the shooting, that the victim came in to purchase some scratcher's tickets and left. There is security camera footage available, but it is only accessible by the store manager. So once the footage is accessed, the homicide unit begins reviewing it and interviewing the witnesses. At that point, crime scene is called in. So what kind of challenges does a crime scene investigator face? Well, for starters, where do we begin? And in this case, at the time that they arrived, the temperature was about 26 degrees Fahrenheit, and halfway through processing the scene, it started sleeting. So, crime scene investigation is about as straightforward as it gets when it comes to the label on the tin, so to speak. They will start with basic documentation, which consists of taking photos, notes, making diagrams or sketches, putting things in the scene in context with each other. Once they've finished documenting, or at least made headway in that, they'll move on to processing a scene for evidence. So this is all about finding that which is not obvious. They can use different chemicals to develop fingerprints that have been left behind. They will sometimes spray luminol to reveal cleaned up blood, or use hinge lifts that remove trace evidence from different surfaces or from the victim. Once they've processed the scene and started to develop that evidence, the next step is collection. And this is the most vital part of their job, so that us back at the lab are able to do what we do. Because the way that you handle evidence directly impacts how it can be analyzed later. For example, you don't want to keep a bloody item kept in an airtight container where it's going to stay wet, because it can develop bacteria, which will degrade the potential DNA. Conversely, if crime scene or the bomb and arson unit responds to a scene and they want to collect evidence and analyze it later to see if something like gasoline was used to start a fire, if you don't keep that in a metal can or an airtight container, that gasoline is going to evaporate, and now the fire debris analyst can't see if there's anything left behind. Included in this scene, or in this slide, is a diagram from the scene. So up in the top left-hand corner, you can kind of see the gas station with the body outside. There were a couple of cars also at the scene at the time, and about 4 different security cameras at different angles. So our victim's wounds, the victim suffered one wound. It was a shot to the back that exited the wound on the center right side of his chest. This is called a perforating gunshot wound because it enters and exits the body. The store clerk stated that he did not hear any gunshots. All right, so now, collecting evidence. A gas station crime scene in particular kind of poses a bit of a challenge for a crime scene analyst. Hundreds of people can pass through a gas station on any given day, so it's a matter of determining what might have evidentiary value and what is just trash. Well, I should say trash, cigarettes, food, receipts, all kinds of stuff. What do you collect? So ultimately, crime scene settles on several overt items of evidence, things related to the victim, like his receipts, his personal effects, and a few seemingly innocuous ones, just in case. Generally speaking, it's better to collect more than what you think you might need, because it could be important later. Notably, there is no cartridge casing found at the scene. All right, up next is processing the victim. So generally speaking, there will be some processing in the field to kind of get a basic understanding of their position in the scene, identifying any immediately available injuries, and looking at their clothing as the situation permits. But generally speaking, most of the victim processing is going to be at the morgue once the body has been recovered. In this case, we find a spent bullet in the victim's jacket at the morgue, which was sent to Firearms for analysis. And the backpack is also recovered and cataloged. All right, so as you can see, the snow, or the sleeting doesn't let up, and it goes into the next day. The next day, a local business employee finds a backpack and a coat by an electrical box in an alley about 2 blocks north of our original scene. Several witness statements make links between the suspect, or rather, a suspect, the location, and the items that have been left behind. So in the photo on the right, you can see that there's kind of a void in the snow by the box. And why might crime scene take a picture of that? Well, the simplest answer is because that's how they found it. The person who called in the evidence had looked through the backpack and touched some of the items prior to calling it in, which is generally not advisable, but when you don't know what you have, it's not that surprising. All right, so we will start with digital evidence. The digital evidence section in our lab focuses on comparing physical evidence recovered from a crime scene to the videos or photos of the scene that have been provided, typically from a security system. The question that digital evidence is trying to answer here is, are there similarities between the items seen in the footage and the items that have been recovered as evidence? So there are different levels of support that they can provide based on their analysis, which are dependent on the quality of the items recovered, the quality of the video or photos that they're looking at, and how well they can make comparisons between them. It's important to note that while they do their analysis, they're looking for similarities and differences because of a risk for what's called bias. Bias is an unconscious support for an idea that could affect how you do something. So in this case, or in this type of analysis, they want to avoid confirmation bias, which is where you are looking for evidence to support your theory or idea and ignoring evidence that refutes it. So for this kind of work, you might, as an analyst, you might already be biased by the appearance of the backpack in the video and what was recovered, and want to look for similarities because visually it already looks similar to you. But it's just as important to look for the differences when you're analyzing those items. So we'll start with the backpack comparison. This comparison ultimately received level 1 support, which is the highest that digital evidence in our lab can provide. In order to get this, they must have good video quality. There are many characteristics that can be compared in detail. The characteristics are evident in multiple images and in combination. It is possible to make a distinction between two items of very similar appearance, so they could distinguish between this green backpack and a different one, and that there are no significant unexplainable differences. So we have many general characteristics for comparison between these items, and you can kind of see that between the middle photo, which is from the footage, and then the photo on the right, which was recreated in our digital evidence section with the actual items of evidence. So the blue area that's kind of circled on there is a tear in the left shoulder strap, and this was visible in several different angles and consistent throughout, and visible with multiple general characteristics, such as the color and the tone, the horizontal webbing on the back of the backpack, the similar carry handle up at the top, and that it's 2 compartments. The other area of note, and one that played a significant factor in making this comparison, is what's circled in red. There's a knotted portion of the strap that was cut and tied off, and this is, again, seen in several different frames of video. It is seen in combination with other uniquely identifying pieces of the backpack and consistent throughout. So up next, we have the comparison for the jacket. This ultimately received level 3 support, which is a couple steps down from what they can say with the level 1. This means that the video quality is still good, but we are limited in what we can actually see in reviewing the footage. There are multiple characteristics that can be compared in detail. It is likely that they are evident in multiple images, but they may only be able to be observed on one occasion, and the characteristics may or may not be observed in combination. So the jacket has several general characteristics that lend support based on the color, the long sleeves, the fact that it's kind of a shiny, reflective material. But the big point of discrimination that they are not able to get that much information on is the side pockets on either side of the chest. Those chest pockets are difficult to identify in the video. They may have been obscured by the backpack straps. and so they are not good for comparison to the recovered jacket. So we have many general characteristics of the jacket, but we don't have many limited or individual characteristics that we would otherwise use to make a more strong conclusion. All right, so up next we will look at the items that were found in the backpack. Up first, we have several rounds of .38 caliber ammunition that were recovered. We get some basic information from this, but like I said earlier, there is no cartridge case found at the scene, so we aren't able to compare anything found at the scene to the recovered evidence here and see if they're the same type. There is no sign of a firearm in the backpack, and there wasn't one recovered at the scene, so now we're really limited in what we can do for firearms analysis. But with that, let's move on to our recovered bullet. So a firearms analyst used a comparison microscope to develop this image of the bullet. With a single bullet and no other evidence available, you're kind of limited in what you can do. So around the time of this case getting into the lab, a separate case came up that had ammunition of the same style and caliber submitted with a firearm. So the analysts compared the firearm in that case to the bullet in ours. Unfortunately, it was determined that this bullet was not fired from that firearm, so now we're back to square one. Next up is our General Rifling Characteristics Database, or GRC, to get more information about what kind of firearm could have been used to fire this bullet. GRC uses characteristics like the weight of the bullet, the number of the lands and grooves, which come from the rifling of the gun, and the measurements of those areas. So the GRC was searched to see if a manufacturer could be narrowed down. This is not an all-inclusive list. We haven't narrowed it down to just 3, but it does give us an idea of what it's not, which can be just as valuable as what it is. So does this provide any useful information to us? By itself, not necessarily, but the more information that we have, even in limited circumstances, can help us compare to other cases or look for more specific information when future cases come up. In other cases where there is more evidence, we will often use the National Integrated Ballistics Information Network, or NIBIN, which we can use to enter or pull firearms information and potentially link cases. This is a database with a lot of information in it that can help agencies across the US link their cases together when similar or the same firearm has been used in multiple crimes. So let's talk a little bit about firearms analysis in general. The first thing that firearms will do when they have recovered evidence is start with a functionality test on a firearm. So before our analysts are trying to do test fires and gather more information, we want to make sure that this firearm operates in a safe way and it's actually usable. So if this firearm is missing parts or there's something that's broken on it, we are able to take parts from our firearms reference collection and make a gun functional again, if necessary. Next, we perform test fires. We have several kinds of ammunition at the lab where we know where we've purchased it from, what kind of caliber it is, and we'll perform a test fire using the recovered firearm. This is fired into a water tank, which slows down the bullet and makes it safe for recovery. And finally, we'll go to comparison. So this is kind of one of the few things that shows up on TV that actually kind of looks like what they do in the lab. Using a comparison microscope, the analysts will look at markings on the bullet or a cartridge case to see if there is what they call sufficient agreement to make a match. Markings can come from several different areas during the discharge of a firearm. So things like the rifling of the barrel, the firing pin impression, the breech face markings on the head of the round, and the ejection from the cartridge after firing. During the manufacturing of a firearm, there are unique imperfections that are imparted on several different parts of the gun because of the wear and tear on the machines used to make them. And those unique imperfections leave behind markings when a bullet is fired. So we have several different points of comparison just on one round to analyze in a case. In addition to comparison work, the firearms section is also able to perform serial number restoration. So sometimes a firearm used in the commission of a crime has been obtained illegally, and the people who obtain firearms illegally generally don't want that traced back to where they got it from. So people will obliterate a serial number using whatever they can get their hands on, screwdrivers, files, sanders, that kind of thing. There's a portion of firearms training at our lab where one of your objectives is to fully obliterate a serial number and then perform serial number restoration to try and get it back. So during the imprinting of a serial number, the crystalline structure of the metal changes. It's not just like a surface level stamp. It's an impression into multiple layers of that metal. And so as a result, the serial number is imprinted deeper than what might be obliterated. So we have chemical techniques like etching, for example, that remove the top layer of the metal that reveals the serial number underneath. All right. So with that, we'll get back to the rest of the backpack's inventory. The first section that's going to assess the evidence is the latent prints evidence section. They start with collecting all of the items suitable for prints and put them through a process called cyanoacrylate fuming or superglue fuming. Superglue fuming is a preferred method as a starting point because it will adhere to a print but will not damage any of the DNA that's also on the item. This is something that we deal with quite a bit at the lab is, generally speaking, the order of operations in analyzing a piece of evidence. So for example, if there is a bag of white powder, then the detective has submitted for DNA analysis, latent print analysis, and drug analysis. Where do you begin? Because DNA and latents want to know whether or not that bag has something dangerous in it, but at the same time, a chemistry analyst may possibly put DNA on that bag by working it if they're not careful. So to determine who goes first, generally we start with getting a better understanding of what is the most important question at the time. If there isn't any DNA or fingerprints on the bag, does it really matter if there's a controlled substance in it? If there's no one that you can link it to, make that connection, is it relevant to your case? So in addition to superglue fuming, there are several other processing techniques that the section will utilize. Ultimately, what's used on an item depends on if the surface is wet or dry, porous or non-porous, and what it reacts with. Because you want to treat a potential fingerprint left behind on a piece of paper differently than how you might treat it on a metal can. Examiners will typically use every technique available to them and the item from least to most destructive and take photos of the fingerprint along the way. One sec. So, latent print analysis uses a process called the ACE-V method. The first step in that is analysis. The analyst in the case will choose several points of detail on the fingerprint called minutia, which will be used for comparison. These are unique markers that we'll talk about in a little bit more detail later. C in ACE-V is for comparison. Once they have chosen those points of minutia, they will take it to comparing, ideally, to a suspect that has already been part of the case. In this case, because we have no immediate suspects to compare to, the section uploads the print to AFIS, which is the Automated Fingerprint Index System. Unlike what you see on TV, this does not work as sending it to AFIS and then AFIS sends you a result back in 5 minutes that it's your guy. AFIS will send back a list of the top 30 candidates, and the analyst in the case will compare the fingerprint to every single candidate. The top 30 is also sent to the analyst in a randomized order. And the reason for that, again, is bias. Because if I know that the top candidate is the best quality, most likely, 95% likely to be a match based on some algorithm, I am probably going to be more likely to think that it's a match compared to number 27, which only has a 65% match. But algorithms are limited in what they can do. It takes several years of training to be able to pick out the points of minutia and perform these comparisons. And so as a result, we don't want to bias ourselves and disregard a print of quote unquote lower quality just because something has said that it might be. So the last step for the analyst in this case is evaluation. Once comparison is done, the analyst determines if the print is a match, an exclusion, or inconclusive. Inconclusive IDs can happen when the print is of low quality. So unfortunately for us, the people who commit crimes generally don't believe behind perfect, nice, full fingerprints for comparison. Often it's a partial print, or it could be smudged, or it's been worn down with time or weather. So here, the analyst has concluded that John Smith, a previously convicted felon and was returned on the APHIS list, is a match for this fingerprint. The final step in the process overall is verification. So a separate analyst will go through the entire analysis, comparison, and evaluation process independently. They'll pick out their own points of minutia, they'll do their own comparisons, and come to a result. If the analyst and the verifier agree, then we have a match and we can release our result. The person who verified the analysis in this case also determined that John Smith was a match. So up here on the left image, they might be a little difficult to see, but there are several points of blue and pink dots, often overlapping. These are the points of minutia that were chosen by the analyst and the verifier. And you'll notice it's kind of hard to see a mix of dots because they picked mostly the same spots. The print on the right, I've highlighted a little bit more because it was even more difficult to see, was those same areas on John Smith's print. There is no set number of points that may be used or that must be used for comparison, and sometimes we are limited by the quality of the fingerprint again. So let's talk about the science behind fingerprints in general. Fingerprints are unique to every person and start developing while you're in the womb. They develop from a deeper layer of skin than what is surface level, so they will grow back if you've damaged your finger at a level higher than where they develop. For forensic analysis, there are 3 different levels of detail to a fingerprint, and the level 1 is the most general. This is ridge flow. So there are 3 patterns that we see in fingerprints: loops, arches, and whorls, and they appear in different abundances in the human population. The field of identifying a person based on their body characteristics has evolved significantly over the last 150 years or so with forensics. We used to have a system called the Bertillon system that measured things like the length of the foot, the circumference of the head, the measurement from like the end of your hand, and they used that as an identification system until there were 2 people in a prison that had the same name and had the exact same body measurements. So that really doesn't work for us. After that, there was developed a system of identification that was based on which of these patterns was on each of your fingers, which creates a couple thousand different categories that you could fall into, but again, is still pretty limited in how identifying it is. So we've moved on to picking out minutia and doing those comparisons. All right, so level 2 detail is all about the specific ridges and how they appear. So in this picture, we have a few different examples. We have bifurcation, which is where a ridge will split into 2. We have a ridge ending where it will terminate kind of in the middle unexpectedly. And then a dot, which is where a ridge or a portion of a ridge will pop up kind of in the middle of another one. These are where picking out the minutia really begins for an analyst, because these are, and in their appearance and position are going to be pretty unique. And lastly, we have level 3 detail, which is the most specific, and this looks at the pores within the ridges. So like the pores on your face, your fingertips have pores in them where sweat and oils can be released. And level 3 detail is assessing the size, shape, and location of those pores within the ridges. All right. So now that we have a suspect print, we have a positive from APHIS. Let's go back to more of the backpack contents. Up next, we have drug analysis. And again, is about as pretty straightforward as crime scene analysis in that with drug chemistry, we are analyzing a sample and seeing if there are controlled substances in there. We do this by looking at how a sample chemically reacts with different kinds of testing. And this is something that we are able to do even when there is a mixture of controlled and non-controlled substances. So if you have a sample of cocaine that has been bulked up with baking powder, for example, we are also able to separate mixtures of controlled substances. It's very common for us to see things that have multiple drugs in them, generally things like syringes, where people aren't exactly doing clean drug use or doing different drugs and using the same needles in them. So in this case, we have a scale recovered from the suspect's backpack where we find residue of cocaine. And in the victim's backpack, we have a syringe and liquid that were determined to contain methamphetamine. So does this provide us any investigative information about the case? Well, it's possible that they could both be independent drug users. It's possible that they could have some kind of drug-related relationship, whether they do drugs together or that one of them is a buyer and one of them is a dealer. And it could be entirely unrelated to any of the events. It is up to other investigative elements like the detectives to make those connections and determine what value this evidence has. While we do analyze things like this, where we look for residues and we analyze liquids and syringes, generally we see much more frequent samples of things like this. So here we have several different kinds of drugs. In the top left, we have crystal meth or methamphetamine. The top right is an example of club drugs, which usually contain any number of substances. Most commonly, they're referred to as Molly, ecstasy, and DMA because that's what people think is in them. Most commonly, when we analyze them, those have meth and caffeine, so a couple uppers. In the bottom right is kind of the most notorious thing that we've been dealing with over the last few years, which are fake oxycodone tablets. These have usually been determined to contain some kind of fentanyl and then other non-controlled substances like acetaminophen, which is the active ingredient in Tylenol. And in the bottom right, we have cocaine. So we will typically analyze samples like these that come in bulk that have been recovered from a scene or a suspect. And like I said, the most notorious over the last few years has been the rise of fentanyl and seeing that in different kinds of samples. I think, unfortunately, the abundance of fentanyl that we've seen in our lab has tracked well with my time there. When I first started at the lab, fentanyl was a very rare occurrence that we would see, and now it is something that we are working with in almost every day. Based on our most recent statistics of tracking what we analyze in the lab, fentanyl and methamphetamine are tied at 25% occurrence in our cases, so they are very abundant. The biggest challenge for us in drug analysis is when new drugs come onto the field. So for the most part, drug analysis is kind of the same work applied to different kinds of samples. But when there is a new type of drug that reacts differently than what we've ever seen before, now we're at a disadvantage because we don't have standards to compare it to. We don't have an understanding yet of how it reacts to our testing. And we are, again, one step behind the people who are manufacturing and selling these drugs. So this is where the collaboration of forensic science is a big advantage. Drug analysts are probably the most willing to share with each other what they're seeing and how they've analyzed something because, again, it doesn't do any one lab any benefit to have a secret way to analyze mushrooms easier, for example, or to say, hey, we're seeing this new form of fentanyl. Has anybody else seen this? Or, what are the trends with that? It goes without saying, but I will anyway. We face a risk of exposure with almost every sample that we analyze, and as such, we have to take appropriate safety precautions to mitigate that risk. It's just one of the many possible dangers associated with one of these jobs. So now let's go back to some additional information that came from the security footage. So remember how I mentioned that sometimes there's a challenge with determining what to collect at a crime scene? The reality is sometimes you don't know until you do, and then it's a race against the clock. So during further review of the security footage, detectives spotted that the suspect used and discarded a tissue at the scene. They hurry back to collect the tissue and submit it for DNA analysis. A DNA profile is developed from the tissue and submitted to CODIS, which is the Combined DNA Index System. And they are searching for a possible match. CODIS is a database for convicted offenders, unresolved crime scene evidence, and missing persons, and serves at different levels. So there's a state level and a federal level CODIS. Like NIBIN, this is a system that can help us link cases together by linking convicted offenders or people between cases. It can unfortunately take a while to get a CODIS match, so if you even get one. So while we wait on that, let's go back to the jacket. Digital evidence indicated that there is support for the jacket collected at the scene to be the same as the one in the video. So as a result, this has possible evidentiary value for us, and we want to, get as much evidence out of it as we can. The jacket is determined to be a better possible source for evidence than the backpack, and so we have additional sections performing analysis. First up is biology, which swabs the jacket for DNA, but finds that the sample has 4 different contributors to it and makes it unsuitable for comparison. Up next is the trace evidence section, who swabs for gunshot residue, or GSR. GSR is a mix of explosive primer, propellant, and vaporized metal particles. This is discharged when a gun is fired and typically doesn't travel far, at most about 3 to 5 feet. Trace analyzes the swab using what's called a scanning electron microscope that is looking for metal particles for lead, barium, and antimony, which are the most commonly found in GSR. And it is determined that the coat is positive. So what does this mean for us? It means that there was either a firearm discharged in the vicinity of this jacket, or that someone wearing this jacket possibly came into contact with someone who had fired a gun recently. All right, and now we go to our final pieces of evidence from the backpack, and DNA takes their turn. So after assessing the backpack for a latent print value, biology is going to take a look at it, and there are a couple top pieces of evidence that are determined, which are nasal spray and a toothbrush. Why would those be considered good for biology? Because they're going to be used in places where you'll find plenty of DNA, the nose and the mouth. Analysis on the nasal spray shows 3 contributors, which is not a fact that I want to spend too much time on because I find that gross. But there is one major contributor, which makes it suitable for comparison. So even in a mixture, not all hope is lost if you have one profile that's determined to be more abundant than the others. The toothbrush, thankfully, only has 1 contributor, and we can all have a sigh of relief at that. At this point, the DNA sample taken from the tissue and entered into CODIS comes back with a hit to John Smith, which is the print that we identified earlier. So now the DNA developed from the nasal spray and the toothbrush can be compared to the DNA from the tissue. Everything comes back as being a strong comparison, so there is now enough evidence to what is called subpoena, which is basically a legal requirement, to get a subpoena for Mr. Smith to submit a DNA sample to law enforcement. This will be used for comparison on all of the items again, now that we have a known DNA profile of what we've collected. So kind of the theme that you'll see, that you've seen in a lot of this analysis, is that we are comparing known objects, things that we know the source of, to unknowns, which are usually recovered from a crime scene. So in this example, the sample that we've collected from Mr. Smith is considered the standard. We know where it came from and we know whose it is. And our unknowns are all of the DNA that has been found on the evidence. Even though we've gotten CODIS hits and we've made good comparisons that they are likely matches, we want a comparison to our standards so that we're able to make a stronger argument for that. So DNA is unique to everyone except for identical twins, and it's found in every cell of the body that has a nucleus. And I say it like that because there's a type of cell that doesn't have a nucleus, which is the red blood cell. It doesn't have a nucleus because it's made more room to carry oxygen. So when you get DNA from a sample of blood, you're actually getting it from the white blood cells that are present. In DNA analysis, the examiner will compare the results from 24 different genetic locations. Through the math used in that analysis, we form what's called a likelihood ratio, which is a way to compare how likely two different competing ideas are. So, for example, let's say we swab your phone and we get a DNA profile on it. And we get a standard from you because we want to compare the two. We could compare those and analyze two competing ideas, that the DNA on the phone is yours or that the DNA on the phone is a stranger. And we do that by comparing the math and the statistics on the 24 different genetic locations. So what if I said it's 10 times more likely to be your DNA than a stranger's? Well, that doesn't sound bad. How about 1,000 times more likely? That's better. What about if I said it was over 1 million times more likely to be your DNA than that of somebody else's? The higher your likelihood ratio, the stronger support that you can make for your conclusion. So the lab gets the DNA results from comparing the spray and the toothbrush to our standard, and let's review all of our findings. So digital evidence has provided support for both the backpack and the jacket, being the ones in the video. Latent Prints finds John Smith's fingerprint on the Q-tip box from inside the backpack. We find Smith's DNA on multiple items related to the case, all items being over 1 million times more likely to be his than someone else's. Trace evidence found gunshot residue on the jacket, which we know doesn't travel far, and the jacket has support for being next to or worn by Mr. Smith and dumped by him in the alley a couple blocks north. Firearms and chemistry performed their analysis, but we are not able to make a connection from these pieces of evidence to other areas of the case. Unfortunately, not every piece of evidence provides a connection, and that's just the reality of what we do. Detectives have several witnesses who recognize Smith as interacting with the victim, wearing the discarded items, and being in the area of the shooting. And we also took into consideration the person who found the bag, the lab analysts, and CSI. So when you work for a police department or a government agency, you often submit your own fingerprints and DNA. And the reason for that is because in the event that you accidentally leave behind a fingerprint or you accidentally sneeze on your drug bag and leave a bunch of DNA behind, we want to know whose it is, and we want to be able to rule out unknown contributors. So we have DNA and prints were also collected from the person who found the backpack and were compared to those items. He is determined to be excluded from any of our analysis. And with that, I will step outside of my scientific lane and ask, what do you think? You think he's guilty? This you can't answer. All right. So our outcome. Suspect John Smith is found guilty at trial of second-degree murder and armed criminal action. He requested and was granted a retrial where he represented himself. I generally don't provide legal advice, but the one I would recommend doing is not representing yourself in court. He was convicted again and sentenced to 32 years in prison. And now that we have resolved our case, let's get back to what it takes to get here. So the name of the game in education is a bachelor's degree in a physical science for most of these fields. For biology, like I have up there, biochemistry or molecular biology. The chemistry and trace sections would be good with a chemistry or biology degree. CSI, firearms, and latents will take any hard science, and we'll touch on that in a moment. And digital evidence is kind of the outlier in that you want a computer science degree, but makes sense. They're not working with kind of the same stuff that the rest of us are. So most of the training for these jobs, and especially things like crime scene, firearms, and latent prints, will come from the work you're doing after you're hired. It's difficult to get training for those kinds of fields in a way that's meaningful in your undergraduate education. And so as a result, it's more important that you have a foundation of scientific knowledge than anything else. So if you have that basis of science, we can teach you how to do the job. I would advise that you steer clear of criminal justice programs because, as I've said, the field of forensic science is shifting from law enforcement officers to scientists being the ones to perform the work. Criminal justice degrees and programs are much more suited for actual law enforcement. But if you feel really strongly about having a criminal justice flavor to your degree, I would recommend making it a minor or taking a bunch of electives in that. Forensic science degrees at the bachelor's level are a little risky, in my opinion. They may not cover as much science that would make you a good candidate for non-forensic fields. So if I have a degree in chemistry, I can go to a wide variety of chemistry jobs. But if I have a degree specifically in forensic science, it may be more difficult to apply that to non-forensic fields of chemistry. Lastly, a master's program in forensic science is a lot of work. Grad school is no joke, and hopefully far off for many of you. But it may make you more competitive when applying for jobs. Due to, let me get to actually the special requirements for this field because it's a little different than applying for a normal job. Background checks and polygraph exams are generally a requirement for most law enforcement or government jobs. Moderate lifting, physical work is sometimes involved. We work in a lab where we have supplies that need moved around, we have instruments that we perform maintenance on, and so being physically able to do those things is important. We have potential exposure to many different hazards depending on the type of discipline you're working in. There's also exposure to confidential information on high-profile cases and also non-high-profile cases. Information security is taken very seriously by law enforcement systems, and there are internal policies and laws that will punish someone for finding or sharing confidential information that they are not supposed to access. Lastly, I'll touch on drug use and arrests. Generally speaking, the cleaner your record, the easier your application will go. When I applied for this job, I was told that my background investigator said that my background was quote unquote boring, and I take that as a compliment. Some states have legalized certain drugs. For example, Missouri legalized marijuana within the last couple of years. But I can tell you that if a drug is still federally illegal, or you're taking something that can be prescribed but was not prescribed to you, that's what they will focus on. Different agencies have different policies on what they consider acceptable. Some say that you cannot have any drug use ever in your history. Some will say no drug use within the last 10 years. It kind of depends on the agency. And the most important factor here is that you are honest in your work. That goes back to the importance of testifying, and that if you cannot be trusted to convey information about you, how can you be trusted to convey information about what you did in a case? And lastly, I'll talk a little bit about my path to forensic science and the things that kind of benefited me in job hunting. I will say my situation for getting my job was a little unique in how smooth it was, but there are definitely advantages that you can get by what you do in college. So I got interested in the field by watching CSI way too young as a kid, and now I can't watch those shows anymore because they are so inaccurate. I graduated with a Bachelor of Science in Chemistry and did a couple things during college that really helped me make me more marketable as a new grad. I spent 3 semesters, or about a year and a half, in a research lab, and that did work that was unrelated to forensics directly, but it helps with developing skills like detailed note-taking, critical thinking, and reporting your findings, which are things that I do every day as a forensic scientist. I also spent time in an organization that did public science outreach. This consisted of doing like chemical demonstrations for the community and schools, and that helps me develop the skills to communicate science in a way that makes sense to people. I applied the summer after graduation and got the job in about 6 months. That's a pretty fast turnaround time. Usually it's a little bit longer. And I spent 9 months in training as a drug analyst before I started any casework. That is, again, also kind of fast, but drug analysis is pretty straightforward as a discipline. Most analysts will spend about a year and a half to 2 years in training before they do real casework. And I'm currently trained in the 3 sections that we mentioned earlier: drug analysis, fire debris, and as a BPA technician. With that, that is the end of my slides. Are there any questions? Yes.
You did decide that you wanted to go into forensic science before high school?
Yes. I knew as a kid, I was like 9 years old, and I was like, I want to be a scientist, and I think I want to be a forensic scientist. And thankfully, due to some personal connections, I was able to meet with scientists at the Johnson County Crime Lab when I was in high school and really develop the understanding of I need to get this kind of degree when I'm in college in order to make me marketable for this field, and these are the classes I need to take, that kind of thing. And now I share that information as much as I can to help everybody else too. But yeah, I knew at a relatively young age that this is what I wanted to do. Yes.
In your best opinion, what part of the job is most likely to be tampered? Can you repeat the question?
Yeah, so the question is, what is the most likely part of the job that could be tampered with? And I'll say, I think more than anything else, it's if someone is dishonest about something that happened. It is much easier to come clean with a mistake than it is to make a mistake and lie about it and then have that discovered later on in your work. If you accidentally analyze something before you get the weight of it initially, it's more important to note that than to pretend it didn't happen, because that could come back later to haunt you. Second highest, I would say, is probably chain of custody, and that is something that we can only control so much of in the lab itself. The chain of custody is the list of the people and entities that held onto a piece of evidence and who it went to and from. If that chain of custody is broken at any point or called into question, it can throw out an entire case, because now it's no longer reliable to determine that this evidence was untampered with. And it's entirely possible for, again, somebody to make a mistake with chain of custody or forget to transfer it timely, that kind of thing. But that is fixable if you are honest about your mistakes and call them, call attention to them, and so that we can resolve them. But yeah, I would say dishonesty in any capacity of the work that you're doing or what happened in a case is what would mess with it more than anything else. Yeah.
Have you been involved in any high-profile cases?
I have been to, as a BPA technician, I do limited crime scene response. So I have been to a few cases. Most of the time when we're called out for bloodstain documentation, it's because there has been a bloody homicide. So in that sense, I've been to cases that are more than just like a breaking and entering or anything like that. As far as like specific high profile ones, even if I was involved, I wouldn't be able to tell you about them. All right. Yes, go ahead. I was told this day one by the lab director after I was hired. You don't go into forensic science for the money, which is true. I mean, I make enough that I am comfortable, that I live in Kansas City, and that I'm happy with where I'm at, and that I'm able to pay the bills and save, and all that's good. I'm not going to be rolling in dough ever, but that's not why I got into the job. Yes.
What's your favorite part of your job?
I think my favorite part of this job is that, in my opinion, there isn't quite a science that has so much output that also feels productive. At least for chemistry, when I was in college, there are kind of two main paths. You either go into academia, which is a lot of like writing grant proposals and trying to come up with research ideas and a lot of trying to get money for the work that you're doing, or you go into industry, where you're working on very well-developed processes and you're creating a product or a material. Forensics is kind of neither of those. There are aspects to both, in that I do a lot of the same repetitive work every day in drug analysis, and that I do have to do my own research for certain things. But ultimately, the outcome of my work does have an impact. So that's what I like the most about it.
That's all the time we have.
All right.
For 5 minutes.
Yes,
Someone's
absolutely.
shy. Okay.
Yes.
Okay, that's all the time we have. Thank you guys so much for coming. Students, I will be up there as soon as possible to stamp your notes. And Patrick's going to be here for 5 minutes. If you're a little stage shy, you could ask him a couple more questions. But thank you so much for coming.